So, good morning all. Today we will see the solution of our seventh problem set. The first question is, in a non-magnetic medium, E equals 4 sine 2 pi into 10 raised to 8 minus 0.8x. A is at volt per meter. Then you have to find A, B and C. So, first what you have to do is you have to compare this equation with our standard equation. E is equal to E naught sine omega t minus beta x a z. So E naught is 4, omega is 2 pi into 10 raised to 7, beta is 0.8. And what does this x indicates? X indicates the direction of your electromagnetic wave. So if it is beta x, then I can say the electromagnetic wave is along the x-axis. If it is beta y, then electromagnetic wave is along y-axis, and if it is beta z, then the electromagnetic wave is along the z-axis. So here the electromagnetic wave is along the x-axis, and here there is AZ unit vector is written here, and that shows that your electric field is along the z-axis. So H will be along which axis? H will be along, the magnetic field will be along the y-axis. So here it is written, compare the given equation with your standard equation. And one more point that you have to keep in mind is, while we went through the topic pointing vector, I told you that the pointing vector and electromagnetic wave will be along the same direction. So here the electromagnetic wave is along the x-axis, hence pointing vector will also be along the x-axis. It will also be along the x-axis. Okay, so pointing vector and electromagnetic wave are along the same direction. Okay. So here it is E naught 4, omega 2 pi 10 raised to 7, beta 0.8. Now the medium is a non-magnetic medium. Till now we were coming across only three types of medium, which are the free space, dielectric medium and conducting medium. And we know only the expression for these three mediums. So among these three mediums, this non-magnetic medium will fall under which one? Is it a perfect dielectric? Is it a perfect conductor? Or is it a free space? So for that, what we will do is, we have the propagation constant equation for the three mediums. That is, for free space we have beta equals omega by c. For dielectric we have beta equals omega into square root of epsilon, and for conductor we have beta equals square root of mu omega sigma by 2. Okay, so first we have to find out the propagation constant. In these two cases, dielectric and conductor, we can't find out beta because we don't have the value of mu and epsilon in the first case, and in the second case we don't have sigma as per the given question. So it is understood that the given medium is not a dielectric or a conductor. Then the possibility is whether it is a free space. So free space beta is equal to omega by c. Omega we know what is it, 2 pi into 10 raised to 7, and c equal 3 into 10 raised to 8. When you calculate, you will get beta equals 0.29. Okay. So this is the calculated beta, 0.29, and as per the question, beta is 0.8. So I can say that since a given beta is not equal to omega by c, then it is understood that it is not a free space. Hence a non-magnetic medium is a lossless medium whose beta is equal to omega into square root of mu epsilon, and whose attenuation is alpha equal to 0, because it is a lossless medium. So I can say alpha is equal to 0. So the conclusion is, a non-magnetic medium is a lossless medium whose attenuation coefficient is equal to 0 and beta is equal to omega into square root of mu epsilon. So what I did is I tried to find out the beta value. The beta value of dielectric is not possible to find to be calculated. Similarly that of conductor also, because we don't have enough parameters. So it's only what we can do is we can find the beta for free space. So we found out, and it was finally we have to come under the conclusion that this beta is not equal to this beta. So again we have to say that it's not a free space. So since it is not a free space, we have to conclude that it is a lossless medium whose attenuation alpha is equal to 0 and beta is equal to omega mu epsilon. And another point that you have to keep in mind is, for a non-magnetic medium, mu is equal to mu 0 and epsilon is equal to epsilon 0 epsilon r. So these 2 points you have to keep in mind. For a non-magnetic medium, mu is equal to mu 0 and epsilon is equal to epsilon 0 epsilon r. So see, these are the few conclusions that we have to come across in order to solve this problem. Okay. So now for a lossless medium, you know what is beta. Beta is equal to omega into square root of mu epsilon. And what is mu? I can write it as mu 0 mu r and epsilon as epsilon 0 epsilon r. Next what I am going to do is I am going to multiply the numerator and denominator by square root of mu 0 epsilon 0. So finally I will get something like this: omega into square root of mu 0 epsilon 0 into square root of mu r epsilon r, which I can write it as omega by c into square root of mu r epsilon r, because we know c is equal to 1 by square root of mu 0 epsilon 0. Now I told you that for a non-magnetic medium, mu is equal to mu 0. If mu is equal to mu 0, then it is clear that mu r will be equal to 1, because you know what is mu. Mu is equal to mu 0 mu r, right? So if mu should be equal to mu 0, then mu r should be 1. So we have beta is equal to omega c. Here you can substitute mu r equal to 1. So finally you will get beta is equal to omega c into square root of epsilon r. Beta, you know what is the value of beta. Beta is 0.8. Beta is 0.8. Then omega and c, you know, from that you will find out the value of epsilon r. Okay. Next, for a lossless medium, we have the intrinsic impedance eta as square root of mu by epsilon. Again, mu 0 mu r by epsilon 0 epsilon r. Mu 0 value you know, mu r value you know, epsilon 0 value you know, and epsilon r value, here it is 14.59. You substitute and find out the value. You will get it as 98.7. That is your first section. Next, you have to find out your the time average power carried by the wave. So you have to come to your Poynting vector or Poynting theorem. P is equal to E cross H. Okay. So in the question it is given E is equal to 4 sine 2 pi into 10 raised to t minus 0.8x Az. Then we can use the expression E by H is equal to eta. From that we can find out H. What is it? E by eta. So I can write H is equal to 4 by eta sine 2 pi 10 raised to t minus 0.8x Ay. We know the magnetic field will be along the y-axis. So this is my B. Now next what I am going to do is I am going to substitute this A and B in my equation 1. Simply cross multiplying. So I will get P is equal to 16 by eta sine square 2 pi into 10 raised to 70 minus 0.8x Ax. As I said earlier, that Poynting vector will always be in the direction of the electromagnetic wave. Then eta we found out, what is it? 98.7. You can substitute it. Okay. Now you have to find out the average power density, that is P average of x. Here I have written x in order to show that the Poynting vector is along the x-axis. If the Poynting vector is along z-axis, here you can write it as P average of z. So here you can write the direction of your power density. So power density. So that you know that is equal to 1 by t integral of 0 to t p dt. So p is here. You can substitute here dt. So you will get this one, this term. So this sine square can be written as 1 minus cos 2 theta by 2, and you know this term will be equal to 0. This will be equal to 0 because if cos and omega t is integrated over a time period t, the integral value will be equal to 0. So finally you will get this for 0.162 t, 0.162 t integral 0 to t of dt. That finally you will get 0.081 ax watt per meter square. The unit of P average of x, that is the average power density, is watt per meter square. Now that is your second section of your question 1. Now the third section is you have to find the total power crossing a surface area of 100 centimeter square across a plane 2x plus y equal to 5. So for that you have to use the last expression which we came across, the average power density of a Poynting vector in the earlier video. So that is this expression. The total power over a surface is given by P average is equal to surface integral of P average x ds. So this is the expression to find out the total power over a surface. So P average you got it as 0.081 ax. So that is a constant that you can take it out. Then finally you will be having only integral of ds. So the integral of ds I can write it as what? S. Integral of ds is s. So when I remove the integral from this formula, I can write it as P average of x s into a unit vector. You can see one more term, a unit vector, because the first module I told you that if you are considering a surface or a plane, whatever it is, and if you take a small area ds across that surface, then that ds will be pointing perpendicularly outward to that surface. That means, I repeat, if you consider a total surface S, and if you are taking a small area ds from that S, that ds will be pointing perpendicularly outwards with respect to the surface S. That means this ds is a vector quantity. It has not only magnitude, it has direction also. So in order to represent the direction, we will be using this unit vector. Hope it is clear. So I repeat, P average is equal to integral P average of x ds. P average of x is a constant and we got it here. And then remaining I will be having the term ds, which I can integral ds, which can be written as s. Along with that I am adding one more term, that is the unit vector. The reason is ds is a vector quantity. So vector quantity should be having a direction. So for that you have to find out the unit vector. So what will be the unit vector? In the question it is given the plane is what? 2x plus y. So the unit vector of 2x plus y is 2ax plus y by what? Square root of 2 square plus 1 square, that is 5. So you can write it as 2ax plus ay by square root of 5. Okay, so that you can, now you can multiply it. When you open the bracket, ax into x will give you 1, but the second term will be 0 because it is ax into ay. So finally you can calculate it and you will get 724.5 microwatt. The point that you have to remember is, if you have to find out the total power over a surface, then the unit will be watt. Please keep in mind the unit is watt if you have to find out the total power over